In this video, we are going to write the algorithm for an epidemiology problem which talks about the following problem. Let's say that at day 0, there are n people infected with an infectious disease. Let's assume that every one of these n people, they can infect r number of people only the next day. After that, they cannot infect anybody. If we want to see how many days it will take to have p people infected, what is the algorithm for that one? So we have to create an algorithm called epidemiology, which takes three inputs, p and r. P represents the number of people that have to be infected. N is the initial number of people which are infected, and R is the number of people that can be infected by each person the next day. So let's see how this one looks. We start at day 0 with n people infected. We know that each one of these n people, they can infect R people the next day only. So the next day, we are going to have n times r new people infected. So the total number of people infected is n plus n times r. Another day is passed. These people, n people, they can't infect anymore because it's past the first day. But these people, they can infect r more people. So each one of them, they can infect r people. So it's going to be n times r times r. Each one of these, they can infect r people. So the whole number, which is nr, can infect n times r times r. If we continue, the next day, these number of people, they cannot infect anybody. But these, they can infect r people, each one of them. So the total number of new infection is going to be n times r times r times r. If you look at this one, this is really n. This one is n times r exponent 1. This one is n times r exponent 2, n times r exponent 3. And if we write the days at the bottom, this is 0. This is day 1. This is day 2. This is day 3. The total number of people which are infected after 3 days is the sum of all these n plus nr plus nr squared plus nr cubed. So this is what we have to do with our algorithm. Let's check one of these to see, if the answer is correct. Let's go with this one, the first one. So I'm going to erase these. We start with one person which is infected, day 0. Each person can infect 5 people. So the next day, I'm going to have 1 times 5 people infected, which is 5. Another day is passed. This person cannot infect anymore. But these can infect 5 more people, each one of them. So the number of infections is going to be 1 times 5 times 5. Again, another days passed. Again, we are continuing days because the number of infection, the total number, if I write it at the bottom, this is 1, this is 5, this is 25. If you add them, 25 plus 5 is 30, plus 1 is 31. It's not 750. So I have to continue. This one becomes 1 times 5 times 5 times 5. But 5 times 5 is 25 times 5 is going to give us 125. Now, if you use your Is our calculator, we see that 1 plus 5 is 6 plus 5 is 31 plus 125 is 156, which is not 750. So I have to continue one more day. So it's going to be 1 times 5 times 5 times 5 times 5. Now, 5 exponent 4, if you use your calculator, is 625. So this one becomes 625. Now, if I add 625 and 125 plus 31, I'm going to get 781, which is more than 750. So it takes 1 day, 2 days, 3 days, and 4 days to infect more than 750 people. So you can see how this one works. So we're going to write the algorithm to accomplish this one. So let's start writing the algorithm. We are going to start with line 1, which is going to be start using the dots for indentation. Then the next line, I'm going to set days to be equal to 0. Then I'm going to say the total number of infected people I'm going to represent with infected, which is initially n on day 0. And then I'm going to keep track of new infection. So I'm going to say new infection initially obviously is n. Day 0, you have n number of people infected, so the new infection is n. Now I'm going to go through a loop and I'm going to check to see if infected is less than or equal to p, continue with the loop. The reason that we say equal, because if you look at the problem, it has to be more than p. So even if it's equal, we're gonna continue incrementing the days. So this line 6, the first thing I'm going to do, I'm going to increment my days by 1. Remember that every day we are going to multiply the new infection of the number of people who were infected yesterday by R. So we are going to say new infection is equal to new infection times R. Now these number of new infections, we are going to add it to infected people. So we are going to say infected is equal to infected plus new infection. Now I'm going to go to the top of the loop, which is line 5. So I'm going to say go to 5. And then I'm going to continue and then end if. Now, when I get out of the loop, this means that the infected people are greater than the number of p, the number p that we are requiring. So I can just go and return p. And then 12, I'm going to end it. So this is my algorithm. Let's try it with a simple one like this one, 10, 2, and 1. When I call my algorithm with 10, 2, and 1, let's see what will happen. This means that p is equal to 10, then n is equal to 2, then r is equal to 1. The first line of algorithm says days is equal to 0. Then the number of infected people are n, which is 2. So infected becomes 2. The next line says new infection is going to be equal to n, but we know that n is 2, so the new infection is 2. Now I'm going to go through the loop. Is infected, remember infected is 2. Is 2 less than or equal to 10? Yes. Then the days is incremented by 1. So days becomes 1 because days is 0. And new infection is new infection times r. So new infection becomes new infection. The previous one is 2 times r. So it becomes 2. And then infected is equal to previous infected plus new infection. So infected becomes infected, and the infected was 2 plus new infection is 2, so it becomes 4. Now it goes to the top. It checks, is infected less than or equal to 10? You can see infected 4 is less than or equal to 10. That's right. Then it's going to come down and it's going to increment days. So days becomes 2. New infection becomes the previous new infection times 2. Previous new infection is 2 times r. R is 1, so it becomes again 2. So new infection still is 2. Then the infected is going to be incremented by new infection. The new infection is 2, infected is 4, so it becomes 6. So infected becomes 6. Now it goes down, goes to 5, is infected. Infected we found is 6. Is 6 less than or equal to p? P is 10, yes. Then days is incremented. So days becomes 3. Then new infection is new infection times r. R is 1. So new infection was previously 2, so it becomes still 2. And again, it's going to be added to the infected. So infected becomes 8. Then it goes to the top of the loop. Is 8 less than or equal to 10? Yes. Then it's going to increment days. Days becomes 4. And the new infection becomes new infection. The previous one times r. New infection previously was 2 times 1, which is r. This gives us again 2. Again, it's going to be added to infected. So infected becomes 10. Now it's going to go top the loop, and it says is infected, which is 10 less than or equal to 10? Yes. So again, it's going to add the days. So days becomes 5. New infection again still is going to be 2 because the previous one is 2 and r is 1, and is going to be added to the infected. So infected becomes 10 plus 2 is 12. Then it goes to the top of the loop and it says is 12 less than or equal to 10? No, it gets out and returns p. Oh, which is wrong. It returns days. And it returns days, which is 5, which is exactly the same thing as the example here.